Welcome to Module 7 of Applied Statistics. This is Brian Powers, and we're going to be going a little deeper into linear regression and looking at some of the hypothesis testing that we can do with linear regression. So we want to just look a little again at the real technical model for linear regression. As we've seen before, we've got data collected from a population, pairs of data, X and Y data, right? So your X's are your explanatory variable, sometimes called a predictor variable, and your Y's are a response variable or a predicted variable. There's a couple other words that are used, but usually explanatory and response are the idea. So the idea would be that the value of X is a way of explaining the value of Y, and Y kind of responds to the value of X. And so the linear model, is that every value of Y, so I'm indexing them with i's, so I could be 1, 2, 3, that's just the little subscript index. Yi is going to be the slope beta 1 times xi. So in giving it beta 1, that's just the notation used for the slope. That's the true parameter of the slope in the model. No, not in the model. That's like in the real world, right? We're trying to estimate that. So beta 1 is the slope times your xi plus beta 0, which is the intercept, and then plus this epsilon I. So epsilon is some randomness, some random variability that's added into the mix. So you could think of it like, a linear model is very simple and it doesn't capture all of the different factors that are involved in explaining Y. So we kind of throw the rest of them all into this random variability term. And one of the assumptions in linear regression is that this randomness involved has a normal distribution with a mean of 0. Now we're never going to be trying to estimate the epsilons, but we can use the standard error of our model as an estimate of the standard deviation of that normal distribution. So now we want to look at what hypothesis tests we can do for linear regression. Since we're really trying to estimate the two parameters, beta 1 and beta 0, we're going to be doing hypothesis tests on the values of those parameters. So let's look at beta 1. That's the slope. And so if we're primarily concerned with, does the slope equal some value or does it not equal some value? And the value that is most interesting is 0, because if the slope is equal to 0, that means the value of x has no effect on the value of y. In other words, there's no linear relationship between x and y. So the way we set it up is we say the null hypothesis, the slope equals 0, beta 1 equals 0, versus the alternative that the slope does not equal 0. Now we estimate the slope with the coefficient b1, as we've done using StatCrunch. And b1 is a random variable because it's a statistic coming from our data, so it has a sampling distribution, and it's going to be related to a t distribution. So it will produce a t statistic, which we can get a p-value from. And its standard error will be abbreviated or notated S subscript b1. And so the b1 divided by sb1 is going to be follow a t distribution under the null hypothesis, and that's what we're going to use. So that will give us a p-value, and we can say whether the p-value is small enough to reject the null. So if we reject the null, that's rejecting the idea that the slope is equal to 0, and so we're going to say there is significant evidence from the data to suggest that the slope is non-zero, which means there is a linear relationship. So that's the idea. And of course, you're going to be using StatCrunch to do the hypothesis test and produce your t-stat and your p-value, and you'll see how to do that in the next video. And this hypothesis test can be done also on the intercept coefficient, or the intercept estimate. Another way of looking at whether there's a linear relationship or whether or not this coefficient beta 1 is equal to 0 or not is to do it with a confidence interval. So if we want to do, say, a 95% confidence interval, we can get the critical t-values for that, for the degrees of freedom that we need, and multiply it by the standard error to give you a margin of error. So this is a confidence interval just like other confidence intervals that we've gotten. You get a lower bound and an upper bound. And just like before, if the confidence interval doesn't include the value 0, then we conclude with whatever amount of confidence, say 95% confidence, that the value of this coefficient is not 0. Okay, so we're going to extend this just a little bit to what we call multiple linear regression. So far we've been looking at what they call simple linear regression, where there is just a single explanatory variable, x. Now we have a little bit of juggling to do with indexes. So imagine now you've got multiple explanatory variables. We're just going to go up to 2 explanatory variables, x1 and x2. And each of those x variables is going to be collected in the data. So now instead of collecting pairs of data, x and y, we're collecting triples of data, x1, y1, x1, x2, and then y. So you have 2 factors that are used to predict or explain your y. Anyway, that's the idea. I mean, you can use StatCrunch to run multiple linear regression, and again, I do examples of that in the next video. But so what you're going to have is an estimate which includes a slope for each variable, for each x variable, and then an intercept. And remember that this randomness, this epsilon, that's not included in our model for predicting y, because on average the epsilons are equal to 0. And so each of these slopes can be interpreted in this way. Take this slope of x2. So if we had a slope of 5, that means if the other x variable or variables are all held constant and we just increase the value of x2 by 1 unit, then we're going to expect on average a change of 5 on the y variable, right? So each of those slope coefficients, it's interpreted when all the other x variables are held constant, or if they don't change, but this one x variable does increase by a unit. That's what the meaning of the coefficient is. Anyway, that's really the basics. So really, we're just expanding just a little bit into this in this module. Last week's was a doozy, but this is just a little kind of incrementally more. And primarily, you'll be looking at hypothesis testing and p-values and making conclusions about the coefficients and that kind of stuff. Watch my next video on how to do it in StatCrunch, because that's going to make your lives a lot easier. Okay, that's all there is. Bye.